Okay, so we have talked a lot about significance testing, also known as hypothesis testing. We have talked about significance levels. We've talked about how to make conclusions, what p-values are, how to interpret them, so on and so forth. So let's talk about mistakes, right? Mistakes are inevitable in our lives. Now, in a jury trial, what are the two errors that a jury could make? Well, they could either incorrectly say that someone's guilty or incorrectly say that someone is not guilty. So in a significance test, what two errors can we make? Well, we can reject our null when we shouldn't have, or we can fail to reject our null when we should have. Which error is worse? We're going to talk about that. So, this is a very important table. If we're assuming that our null is that the defendant is not guilty, right? That's what we assume in this country. You are innocent until proven guilty. So, if the person is guilty, and we come to the conclusion that they're not guilty, that is right. If a person is innocent, or I should say not guilty, and the verdict is not guilty, that is also the correct decision. Now, if you incorrectly say that someone is guilty when they are not, this is referred to as a type 1 error. Notice how there's an alpha next to it. The chance of making a type 1 error is the same as your significance level. So we usually pick 0.05. So usually there's a 5% chance of committing a type 1 error. If someone is guilty and the verdict is not guilty, that will be called a type 2 error. And that is going to be beta, which we will talk about in a little bit. So, which one is worse? It really depends on your own personal opinion. I think it's pretty bad either way if you put an innocent person in jail or if you set a guilty person free. So that's kind of a matter of personal opinion about which one is worse in the jury situation. So, another way to think about it in terms of our hypotheses. If your null hypothesis is true and that comes to that result, then yeah, that's what you want to do. If your null is true but you don't, and you say that your alternative is true, that will be our type 1 error. Okay? And then same thing for type 2. Happy face, sad face. So, if we're assuming innocent, then the alternative is guilty. A type 1 error, like I said, is to punish an innocent person. A type 2 error is to let an innocent, or not innocent, I should say, guilty person, go free. A way to remember this, if you think about movies, in The Shawshank Redemption, an innocent man who is not guilty is found guilty for a crime that he did not commit and then had to go to prison. A type 2 error, again, this is a matter of personal opinion, but most people think that O.J. Simpson was incorrectly found not guilty for a crime that people thought that he did. So, in terms of statistics, a type 1, if we reject our null when the null is true, right? It's like a false positive. So that's when we finding convincing evidence that the alternative is true when it really isn't. So a type 2 error, if we fail to reject the null when the null is false, right? So a false negative. So not finding convincing evidence that the alternative is true when it really is. Now, this error, whether it's type 1 or type 2, is caused by variability, not by the person conducting the test. Okay, so variability will sometimes cause errors not due to the person that's doing the testing. Another way to think about type 1 versus type 2, a type 1, which is our false positive, would be like a man going to the doctor, and the doctor saying, "Congratulations, you're having a baby." Where a type 2 error, which is our false negative, would be like a 9-month pregnant woman going to the doctor and they're being like, "Nope, you're not actually pregnant. Just kidding." So, different ways to remember our type 1 and our type 2 error. This is another way, another analogy, so you can pick whichever one works for you. If you like Shawshank and OJ, if you like the pregnancy one. I liked this one. It refers more to the alternative than to the null, though. So, if you remember the story of the boy who cried wolf, it does errors in that order. First, everyone believed that there was a wolf when there wasn't. That's like saying everyone is believing the alternative, when you shouldn't have, meaning you rejected your null. So then they didn't believe that there was a wolf when there actually was, right? So they're not believing the alternative when they really should have. So if you substitute the word effect for wolf, that is basically the conclusion here. Effect or the alternative hypothesis. This was a cute little quote that I found once. It's from How to Tell the Liars from the Statisticians by Robert Hooke. It has to do with the Book of Common Prayer. Nothing can be further from statistics than the Book of Common Prayer, wherein it is stated, we have left undone those things which we ought to have done, and we have done those things which we ought not to have done. When the great day comes that statistical education is available to all, we'll be able to shorten this to, we have all committed type 1 and type 2 errors, and everyone will know what is meant. I just thought that was really clever. If you need to read that again, please feel free to pause it, because it is kind of funny. So we've talked about different examples with type 1 and type 2 errors. Let's talk about maybe quality control. So say your null is that the product is acceptable to the customer, meaning the alternative with the product is unacceptable to the customer. A type 1 error is where you would reject acceptable product and then you don't ship it. So mean that loses money for the company. But a type 2 error is where you ship unacceptable product to the customer, and then maybe you make the customer a little bit upset because they're getting product that's not that good. When we draw a conclusion from a significance test, we hope to be correct, but like I said, it's sometimes going to be wrong. These are our type 1 and our type 2 errors. So, just kind of wrapping it up one more time, one more table to show you the difference between them. 2 ways to be right, 2 ways to be wrong. Okay. All right, so let's go through an example. There's going to be a lot of writing, so you might need to pause for a bit. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using these hypotheses. The null is that the proportion is 0.08. The alternative is that the proportion is greater than 0.08, where P is the actual proportion of potatoes with blemishes in a given truckload. Describe a type 1 and type 2 error in the setting, and also explain the consequences of each. So, a type 1 error would occur if the producer concludes that the proportion of potatoes with blemishes is greater than 0.05 when the actual proportion is 0.08 or less. Alright, so you're saying that you're agreeing with your alternative, meaning you've rejected your null when you shouldn't have, right? Your null was true, the proportion was fine. So what's the consequence here? The potato chip producer sends the truckload of acceptable potatoes away, may lose revenue for the supplier. A type 2 error happens if the producer does not send away the truck when more than 8% of the potatoes in the shipment have blemishes. Okay, so it's saying the alternative is true, but we're not saying that it's true. And so we're not sending it away when we really should have. Right? We're saying there's not enough evidence to believe that our alternative is true. So we're saying the potatoes are fine. Well then, we're using a truckload of potatoes that have blemishes. That may upset your customers. This can be confusing. It takes a little bit of time, right? I've been doing this for many years, and it still takes me a minute or two to think about, okay, what's the difference between a type 1 and a type 2? What does it mean in the context of problems? If at first you don't succeed, try 2 more times so that your failure is statistically significant. I just like that. That's fun. Okay, sorry, I had to pause for a minute to take care of a crying kid, but I'm back. So, let's talk about another example. The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait more than 2 minutes to receive their food once their order is placed. Based on store records, the proportion who waited was 0.63. To reduce this proportion, an additional employee is assigned to the drive-through. Random samples of drive-through times will be collected and used to test the following hypotheses. The null, claiming that the proportion is equal to 0.63, compared to the alternative, where the proportion is less than 0.63. So let's talk about a type 1 and a type 2 error in the setting, and then talk about the consequences of each one. So, in this case, a type 1 error would occur if the manager decides that the true proportion of drive-through customers who have to wait at least 2 minutes has been reduced, when in fact it really hasn't been. So what's the consequence here? Well, the manager is going to have to pay unnecessarily for an additional employee when they really didn't need to fix it at all. A type 2 error would happen if the manager didn't decide that the true proportion who have to wait at least 2 minutes has been reduced, when it really has been. So the restaurant would not have an additional employee helping with the drive-thru, so it wouldn't be providing faster service when it could. So consequences of error and also significance level. If the consequences of a type 1 error are serious or expensive, then you want a small significance level. A significance level is the chance of having a type 1 error, of making a type 1 error. So if 2 drugs are being compared for effectiveness, drug 1 is very affordable, drug 2 is extremely expensive. The null is that they're equally effective. The alternative is that drug 2 is more effective than drug 1. In this situation, type 1 error would be deciding that drug 2 is more effective when in fact it's still better than drug 1. But it would cost the patient much more money. And that would be undesirable from the patient's perspective, so you would really want a small significance level. If the consequences of a type 1 error are not very serious, and especially if a type 2 error has a serious consequence, then maybe a larger significance level is going to be appropriate. So let's talk about drugs again. 2 drugs are known to be equally effective for a certain condition. They're also equally affordable. However, there's some suspicion that drug 2 causes a serious side effect in some patients, whereas drug 1 has been used for decades with no reports of the side effect. The null is that the incidence of the side effect is the same in both drugs. The alternative is that the incidence of the side effect in drug 2 is greater than that in drug 1. If you falsely reject the null when it is in fact 2, which is a type 1 error, that would have no great consequence for the consumer, but a type 2 error, aka failing to reject the null when it is in fact the alternative is true, which would result in deciding that drug 2 is no more harmful than drug 1, when in fact it actually is more harmful, that could have serious consequences from a public health standpoint. So setting a large significance level would be appropriate in that case. So what's worse, type 1 or type 2? It depends. But it's going to be impossible to minimize both error types completely. So you kind of have to pick your battle, which one you think is worse, and then go from there. Now, like I said, a type 1 error is always, the probability of making a type 1 error is always equal to your significance level alpha. The type 2 error, the probability of making a type 2 error is 1 minus beta, and beta is what we call the power of a test. So let's talk a minute about power, and then we'll talk about it more later on. In short, power is the probability of not making a type 2 error. So the higher the power, the less likely the mistake is. So you can see here, the blue is the probability of making a type 2 error, and here is the power. The bigger the power, the less likely you don't make a type 2 error. So power, here's what you're going to write down, is the probability that a test will reject the null at a chosen significance level when the specified alternative value is true. So power is the chance you do the right thing. Okay? Power is always calculated 1 minus beta. Power is close to 0 means there's almost no chance of detecting a false null. Power is close to 1 means that it's very likely to reject the null in favor of the alternative if your null is in fact false. So 2 ways that you can increase your power. If you take a larger sample, right? A larger sample is going to reduce the probability of making a type 2 error. Or if you have a higher significance level, a higher alpha. This increases the risk of a type 1 error and therefore changes your chance of a type 2 error. So, I heard you upped your sample size. More power to you. Okay? We're going to talk more about power in class, but here are some results or some summaries of things we've learned. take a moment and read these, and we will do more practice together in class.